In the next part of this lesson, it is very, very important that you attempt to do this before I go over it. There is some practice exercise that incorporates some of the other items we've been doing in this unit. If you haven't done it, please stop now and do it, and then watch as we go over it. It is very important that you try it first. Okay, I'm ready to begin. Problem 1 wants us to approximate g of 8 using a trapezoid approximation method using 4 trapezoids. Please be careful. The lower bound here is 0, so we want to approximate the integral from 0 to 8 using the trapezoid. So I'm going to start at the 0, and I need 4 partitions. 1 partition, 2 partitions, 3 partitions, 4. And those will be the basis for my trapezoids. Okay, so average the base. Base 1 is 5. The other base is 2. Divide that by 2 times the respective height of the trapezoid. That's going to be that change in x distance. For the first one, that's going to be 1. Now for my next trapezoid, it's going to be 2 plus a negative 3. If you wrote 2 minus 3, that's fine. I like to keep this general structure in place, so I write it this way. Divided by 2 times the respective change in x. In this case, the change in x is 4. Plus negative 3 plus negative 10 divided by 2 times respective height of 2. Lastly, we have negative 10 plus 9 divided by 2 times respective height of 1. You can leave your answer like this. Please don't simplify it. You run the risk of having errors in your calculations, but if you did simplify it, it comes out to be negative 12. In question number 2, it wants us to find g prime of 1. Well, that's what we've been talking about a lot in this unit. G prime of x is simply equal to f of x. So g prime of 1 is going to be f at 1, and then I just utilize the chart, and the chart tells me f of 1 is equal to 2. In number 3, they want us to estimate g double prime of 1.3. I will start off by saying g double prime at 1.3 is equal to, see if I come over here, g double prime of x is equal to f prime of x. So this is going to be equal to f prime of 1.3. So they want to find the instantaneous rate of change in f at 1.3, and I have this arrow here to show that that's somewhere between the 1 and the 5. We want to find the instantaneous rate of change. And if you recall, to estimate the instantaneous rate of change, we find the average rate of change, but on a small neighborhood. So f prime of 1.3 is approximately the change in f over the change in x on a small neighborhood. So we'll have f of 5 minus f of 1 all over 5 minus 1. So I can use my chart to compute those. So we have a negative 3 minus 2 all over 5 minus 1. And that, of course, comes out to be negative 5 over 4. Okay, I cleaned it up here a little bit as we enter the last 3 really awesome questions. H of x now is a new function defined to be the integral from 5 to x of f of t dt, and we want to approximate h of negative 2 using a left Riemann sum. It's fancy for saying rectangle sum. So let's see, that's going to be 1 partition, 2 partition, 3 partitions. Good, that's what we needed here. All right, so let's begin this. So h of negative 2 is going to be the integral from 5 to negative 2 f of, I don't need the dummy variable anymore. I don't know if you saw this, because it goes from large to small bound. I'm going to flip it and make it negative. Okay, and now I'm ready to do my work. So I have a negative. Now I'm appealing to the rectangles to estimate the integral from negative 2 to 5. And let's do that now. The first rectangle on the left endpoint, this would be the right endpoint of the first rectangle, I want the left. The height is going to be 14, and the respective change in x is going to be 2. Now, the next rectangle, which comes from this partition, has a height of 5 and a change in x of 1. And the final rectangle has a height of 2 and a change in x of 4. We will not be using this end because that's a right end of one of the rectangles. I could leave my answer unsimplified. I'm happy with it. If you do simplify it, negative 41 is that answer. Okay, here comes the chain rule business. We want to find w prime at 1. To do that, let's first find an expression for w prime. W prime is going to be the derivative of the integral. Let's use our chain rule here. F of 3x squared plus 2 times the derivative of stuff, so times 6x. All right, now we have to find w prime at 1, which is going to be f of, well, if I plug 1 in for x, that's going to give me 5. So f of 5 times 6 times 1 is 6. F of 5, according to the chart, is negative 3 times the 6. That comes out to be negative 18. Wasn't that a cool question? I'm pretty pumped about that one. Okay, number 6. Last one here. We want to find n prime at 1. So an expression for n prime of x. I see the x is in the lower bound. No chain rule required here. So it's simply negative f of x. And so now n prime at 1 is equal to negative f at 1. And f of 1 evaluates to be 2. So minus the value of 2 gives us negative 2.